Welcome back to our course. So for this lecture, we'll be studying about pandas. So a brief introduction about pandas. So pandas is a fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the NumPy library. So this is the Python's version of MS Excel, or if you're familiar with the R programming language. So this is similar to R data frames. It allows for fast analysis, data cleaning, and preparation. It has also some built-in visualization features. It can also work with various data sources. So in order to use Pandas, you import the library as much as like the NumPy library. So for example, import pandas as PD. So this will be the pandas library. You're importing here the pandas library. So before we proceed to data frame, so let us discuss first the Panda series. So a Panda series is a one-dimensional array of index data. It can be created from a list or from a NumPy array. This is very much similar to a NumPy array, but a series has access labels, as you can see later. So let's compare a NumPy array and a Panda series. So if we have some variables here, let's say NP array. So I'm defining a NumPy array. So NP array, let's plug in some values. 0.25, 0.5, 0.75, and 1. So let's look at the array. So this is the NP array. So let's look how about we create a Panda series. So before we proceed again to data frames, so let us discuss first the Panda series. So data, for example, so create a series, you denote as your representation of your pandas library. We define it as PD, so series. Then we create a series. According to this one, we can create a panda series from a NumPy array, such as this one. So Alt Enter. So let's look at the specific data. So as you can see, it has specific indices. So let me annotate this one so you'll clearly understand. So it has specific indices, for example. So you can see here the indices at the side. So 0, 1, 2, 3. Then we have the specific values. So 0.25, 0.5, 0.75, then 1. So the difference between the two, between the NumPy array and a series, is that, as you can see, the series wraps both a sequence of values and a sequence of indices. We can access this one by using the values and index attributes. So the values are simply similar to the NumPy array. So for example, we use the data variable, so data values. So we can identify the values. As you can see, much like a NumPy array, then we can also use the data index. So let me Alt Enter here. So this is the range index. So starting from 0, as you can see, we stop at 4. So it's the number 4. So 0, 1, 1, 2, 3, 4. Then we have a step of 1. So the next one. So how about series as a generalized NumPy array? So like with a NumPy array, data can be accessed by associated index via the familiar Python square bracket notation. So let me display the data once again. So we have this specific Panda series. So if I told series, automatic that's already pandas. So we can also access specific value by using you're familiar with the square bracket notation from a list, from a NumPy array. So it's similar to that. So for example, so data index 1, so we are accessing the value here of 0.5. So we can also do the colon notation. So for example, data will start at index 1, then we will end up at index 3. So again, the last one is same, exclusive. So we're expecting here the values from 0.5 and 0.75. Okay, so that's index 1 and 2. So as we will see, the Pandas series is much more general and flexible than the one-dimensional NumPy array that it emulates. So the essential difference here with a series and a NumPy array is that it has the presence of the index. So while NumPy has an implicitly defined integer index used to access the values, a series has an explicitly defined index associated with the values. So let me demonstrate for example. So assuming I will create another data and another series. So same values, for example, so 0.25, 0.5, 0.75, and 1. So same values. So if you shift tab, so remember the shift tab, so it has a specific parameter of index. So what you can do with index is to explicitly define a specific index. So let me close this one. So we'll define an explicitly defined index. So for example, so we have here the value of index. So it is defined also as a list. For example, A, we have B, we have C. Okay, so we have C. Sorry about that. So we have D. So if you execute this one and we take a look of our data variable again. So as you can see, we explicitly define a alphanumeric index. So as you can see here, instead of 0 to 3, so we have A, B, C, D. So that's the main difference between a NumPy array and a Panda series. So you can explicitly define a specific index. So access to this item can be done with the following. So if you have this kinds of indices, so you can now do this kind of access. So for example, you explicitly define the name of the index now. So for example, data of B. So again, 0.25. So you can also select multiple indices. So you denote it with double square brackets, then A, then B. So Alt Enter. So you're accessing index A and B right here. So another one, so you can also do colon notation. So data, for example, I got A and I want A to C. So for example, so let us Alt Enter. So we're expecting here. So we are expecting here three values. So we denote from index A up to index C. So you can also create a Panda series from a dictionary. So you can also think of a series as a specialized dictionary. As you can recall, a dictionary is a structure that maps arbitrary keys to a set of arbitrary values. Remember our key value pairings? So a series maps types keys to a set of type values. We can make a series from a dictionary as we will demonstrate below. So from this example, we will create a Panda series from a dictionary. So if we have, for example, a population dictionary. So the ICT. So we will create a Panda series from a dictionary. So for example, let me plug in the values here. Okay, so let me copy. So I've created specific values here. So instead of typing, let me copy this one. So this one is a population of US states. So California with a value of numeric value, and Texas, New York. So remember this one, these are key value pairings. So you can create a Panda series from a dictionary. So for example, you define a population variable. So PD dot series. Then you plug in the value of population DICT. Okay. So let us take a look at the population. So this one is a Panda series. So look at the indices. So it's not from 0 to 4, it's not 0 to 3, but you define what will be the name of the indices. So we can also access this one by creating name indices. So for example, you want to access the value of California index. So you type in population, which is the variable, then the name of the indices or the index. In this example, that is California. So again, you can also do multiple indices selection. So for example, I got California. So when you're selecting multiple indices, don't forget to double the square brackets. Then for example, I got here California and Texas, for example. So we have double square brackets right here. So Alt Enter. So we're accessing the value of the California and the Texas. So again, you can also do, although this has a name indices, you can also do numerical indices, of course. So population, just like a normal NumPy array. So for example, index 1, it will end in index 2. So again, exclusive is the number 3. So Alt Enter. So you're accessing here Texas and New York. So why? So this Texas is index 1. Okay. So from this Florida is index 3. So this is excluded, as you learned on the previous lecture. So we got Texas and New York. So it also has displayed the data type, which is integer of 64. So we can also construct directly from a series objects. So how can you construct from a series object? So you already seen a few of construction of a series from scratch. All of them are some versions of the following. So as noted, so you construct a series by using a pd.series. Then the two important parameters, you have data and index, as you see earlier. So where index is an optional argument. So the index is an optional argument. And the data can be one of the many entities of many data types also. So index defaults to an integer sequence. So for example, so I have here PD series. So 2, 4, and 6. So I'm created PD series. So if you will not explicitly define in an index name, so it will default to numerical indices. Also, data can be scaled, which is repeated to fill the specified indices. So for example, I got this one example. So for example, PD series, I got 10. Then I will explicitly define an index. So for example, again, so A, B, and C. Okay, so Alt Enter. So as you can see, A, B, C, all of the value is 10. So it can be scalar. So the index can be explicitly set also if a different if a different result is preferred. For example, we got here PD series. So let's define, for example, dictionary. So for example, A. So we have here, for example, is 1. Then another one, we have B. Then 3 with a value of C. So if you define explicitly the index, which is 2, so actually you can define, you can remove this index. So you define as 2 and 1. So look closely what will happen. So instead of displaying all the dictionary, so as you can see, so the number 3 index is missing because you explicitly define what to display only, what to define the specific index. So you define only 2 and 1. So the 2 and 1 will be shown. Okay? So it will be shown. So notice also that in the case the series is also populated with explicitly identified keys. So you can also combine series such as, so for example, we'll be combining such series. For example, we got for example series 1. So PD series. So 1, 2, 3, and 4. So that is the data. Then, for example, we define specific indices. So, for example, this one is Philippines. So, another one is USA, for example. And let's put here Canada. And, for example, we got here Italy. So, let's execute this one. So, this will be series 1. So, let's create another series. So, for example, series 2. So, PD series. Same data. So 1, 2, 3, 4. So let's create the explicit index, which are the Philippines. Example, we got Germany. Then we got USA. Then we got Canada. Okay. So the first series do not have Germany. So the second one do not have the Italy. So let's combine this one. So let's see what will be the result if we combine this one. So combining meaning we perform some operation. So for example, is series 1 plus series 2. So let's look at the result. So in case of if the second series cannot find a match, so you can see here. So we have a none, so which denotes for not a number. So remember, if you saw NaN, so it will denote, it means that it is not a number. So why is that the case? So for example, we have Canada here of value 3. Then the second series also has Canada, which is 4. So we add that 1. So we got 7. So the first series do not have Germany, but the second series have 1. So it cannot add, cannot find the specified index. So it will result to NaN. Same case with Italy. With Philippines, this will be 1 plus 1. So the result is 2. And for USA, this will be 2. And we have 3. So that's why it's 5. Okay, so it will try to match the operation based of the index. Where it cannot find a match again, it will be a not a number, which is a none. When you are performing operations like integers, it will be converted into floats. Okay, so no, the PD series usually do this. So in order to retain, in order to retain such information, so it will convert this into floats. So this one, so we'll not be using mostly series, but for the next topic, we will talk about what we will use, which is the data frames. We will be working a lot more on data frames, which is the true workhorse of this Pandas library. So again, see you at the next lecture. So I hope you're doing fine. Thank you very much.